Then we have next talk, and there we have Dr. Tom. Thomas got his PhD at CERN searching for the Higgs boson. That Higgs boson is found now, so he moved to the next best challenge, looking for cross-site scripting. And cross-site scripting is also found. It's a different problem, and how he's finding it that he can explain on himself. So give a round of applause to Thomas. To Tom.
Thanks very much. So I'm going to be talking about Project Foxhound today. Like Henrik said, my name's Thomas Barber. I'm currently working at SAP, and we've already heard a bit about SAP security today. I'm going to hopefully give a bit more of a positive spin on things. But I'm giving this talk as the sort of lead maintainer and developer of Project Foxhound, which I'll tell you about in the rest of the talk. So we'll start with some motivation. It's probably familiar to a lot of you. If you have a user and they want to access a website, right? They do it via a URL, obviously. So they will visit this URL, and you'll get some resources downloaded into your browser. Could be some scripts and some cookies containing credentials. Those scripts then get executed in the browser. So if we have a look at a very simple example here, let's have a look at what this is doing. So this is JavaScript executing in the browser. It's taking components of that URL using this location API, in this case just the hash, and performing some kind of operations on it, right? So it's saving it to a local variable. Then we have a substring operation. We're doing some decoding. We've got some concatenation with some static strings. And then that string ends up in this document write API. And the document write API is also very well known. So it will take the content of that message and then append it to the HTML document. It gets interpreted as HTML and rendered into the browser itself. And you can probably see where this is going. So these types of data flows are vulnerable to client-side cross-site scripting. So in the case where we have the same setup, we now have an attacker crafting a URL to our same site. So everything looks good, except they've put some HTML tags inside this hash. And they distribute it via some sort of a phishing email so that our user clicks on that link. So the code that's loaded is the same. The data flow is the same. But now because our attacker is controlling parts of that URL, they're also able now to inject HTML code into the page and in principle execute scripts as well, because the browser can't distinguish between the sort of trusted and untrusted input. And this is what causes cross-site scripting. So we've got an insecure data flow from a source into a sink. And client-side XSS, it's not a new thing, right? It's been around for a while. So it was discovered, like this variant was discovered back in 2005. And the story, the development is also kind of interwoven with the OWASP community. So one of the first sort of big tools which was used to detect client-side XSS was Dominator, which I think was developed by Minded Security. They're very active in the sort of Italian OWASP community. And then a few years later, 2013, there was the well-known paper from Martin Jons, who discovered that 10% of popular websites actually contain client-side XSS. And since then, there's been a series of papers looking at different aspects of client-side cross-site scripting, so it's been studied a lot. So for example, protection mechanisms, the causes of client-side XSS, like improved detection mechanisms and validation techniques, variants, for example, like stored client-side XSS, and some further improvements. And what all of these papers have in common is that they all use a technique called dynamic tainting. And dynamic tainting basically detects these insecure data flows, which I showed a few slides earlier, which are the cause of client-side XSS. And all of the studies which I showed, they use the same technique. So what they do is they instrument the web browser. So you really go into the web browser, you take it apart, you look into the JavaScript engine and the DOM rendering engine, and you sort of take it apart, you add that functionality to do the data flow tracking inside the browser. And if you've ever tried to look inside a web browser code, you'll know this is not really a kind of a straightforward task. So if you think, I've got this great idea, I want to study some property of cross-site scripting, there's a very high initial investment for research groups to go away and do this kind of activity before they can even get to the science. And that was one of the motivations for this project Foxhound, to really reduce this burden for researchers initially to do these kind of studies. So what is Foxhound? So it's an instrumented fork of the Firefox browser, and we're doing exactly that. So we're taking Firefox and adding this dynamic taint tracking functionality to it to do these kind of studies. And currently it's mainly maintained collaboratively between SAP and the University of Braunschweig. And there's a couple of cool features that kind of hopefully make it easy to use. And one of them is that we're trying now to align with the Playwright browser automation framework to allow you to drive Foxhound with an API to automate any studies you want to do. We have detailed data flow information, so not just you've got source to a sink, but all of the functions in between. And it's flexible, so you can configure it. You can configure the sources and sinks you're interested in, so you can not just study cross-site scripting, but it's a sort of a general tool for any kind of client-side vulnerability studies. And the big bonus is it's also open source. So a few years we kind of pushed it through the open source process at SAP, so you can find it on GitHub. So you can take the code, you can download it, you can compile it yourself, and then modify it for whatever study you want to do. If you think this sounds interesting, you might be asking, okay, how can I use it? What do I need to do? So what the Foxhound browser does, you've got that kind of in the middle, providing this framework to do your advanced taint tracking. And then there's two things you need to kind of think about how to implement in order to get a kind of a full-scale study going. One of them is the crawling engine. So you need to think about, okay, how do I want to navigate to web pages? How do I want to extract links or interact with that page? Depending on what exactly you want to study. Like I said, we present this sort of Playwright API. So it's a standard API from Microsoft, which has sort of gained quite a lot of popularity to make it easier to sort of drive the browser itself. And then if you discover some kind of data flow, you get some sort of a callback, some event saying, OK, we found this data. And then you also need to analyze that, right? By default, you get all of the different data flows from every source to every sink. You need to do some kind of analysis, say, is this interesting for my study to detect certain vulnerabilities, maybe do some validation on top of it. And Foxhound has been used in this way in a number of recent papers on both sides of this sort of spectrum. So the ones related to the crawling engine are saying, OK, we sort of want to detect standard cross-site scripting. What happens before and after we accept cookies? What happens before and after we log into the site? And how does the crawling strategy affect our ability to detect XSS? On the other side, we've got a number of studies which are more focused on this analysis side. So there was a study we did looking at the effectiveness of handwritten sanitizer functions. Also a couple of studies looking at new vulnerability classes, and even recently using the same taint tracking functionality to detect browser fingerprinting. So branching out a bit away from security, but applying that Foxhound as a tool to the privacy case. So if you think this sounds good, there's lots of ways that you can get involved. I've talked a lot about security researchers. So if you're interested in using Foxhound as your tool, then please cite the paper on the GitHub page. Also let us know. We're interested to hear how Foxhound is being used. And if you think that the changes you might make for your study are useful for the community, then please open a pull request, get in touch. We'd love to kind of merge some new features and modifications. And actually recently available since yesterday, so David, he's here somewhere over there, has also made some binaries available, right? So it's now even easier. You don't even need to go through the hassle of compiling. We have some pre-made binaries for Linux and some examples also with Playwright to kind of ease that process along. In industry, so not just in the research case, we also heard about Fiori applications earlier on. We have an internal testing tool dedicated to testing Fiori applications, which recently won a sort of industry security award, and that's scanning like 600 enterprise applications every day using this technology. There's a couple of other directions which we could go in. So what would be really nice is to kind of build some infrastructure around Foxhound, integrate it into security tools, for example, like a Zap plugin to automate like the whole process. Another thing where Foxhound could be used is in education. We also heard about the Juice Shop this morning, because it gives a really nice visual, real-time detection of cross-site scripting on your vulnerable page. And you can really see each stage in the vulnerable data flow and kind of inform users and developers why this is happening. OK, that's all I've got for today. Thanks very much for listening. If you want to find out more information, go to the GitHub page and the link's on here. Thank you.